Corona discharge occurs at a relatively high gas pressure, for example at atmospheric pressure, in a strongly inhomogeneous field. In order to get a significant inhomogeneity of the field, the electrodes must differ significantly in surface values. Thus, we can get a corona discharge by placing a fine wire inside a metal cylinder of a big radius. Well, actually, the external cylinder can be substituted by the surrounding earth objects. Electric field lines are thickening when approaching the wire. Therefore, field density near the wire has the biggest value. When it reaches about 3 megavolts per meter, a discharge occurs between the wire and the cylinder, and current appears in the circuit. At the same time, a glow surrounds the wire in the shape of a shell or crown. That is why it is called corona discharge. Such discharge can occur either at a negative potential on the wire, that is negative corona, or at a positive potential, positive corona. It also occurs at alternating voltage between the wire and the cylinder. When voltage between the wire and the cylinder increases, the current in the corona discharge also grows. At the same time, thickness of the corona's glowing layer also increases. The processes within the corona are as follows. If the wire is charged negatively, then at reaching breakdown intensity, electron avalanches are formed at the wire surface. They spread from the wire onto the cylinder and drop off at the corona's edge. The distance which they travel is the size of corona. Thus, the edge of a glowing corona is formed. It is followed by a dark region where current carriers are either negative ions or electrons. Negative ions are formed from neutral gas molecules after electrons attach to them. The discharge in the dark region is a non-self-maintained one. A negative charge in the dark region limits the discharge current. Therefore, electron avalanches in the corona discharge do not permeate gas layer completely. That means it is a partial breakdown of gas gap. In case of a positive corona, the electron avalanches are formed on the outer surface of the corona and move towards the wire. Corona discharge occurs not only near wires but also near any conductor with small surface. Corona also occurs in nature under the influence of atmospheric electric field and appears at the tops of trees and ship masts. The possibility of corona discharge occurrence is always taken into account in high voltage engineering. A corona discharge affects the electric power lines negatively as it causes significant leakage currents. To avoid occurrence of corona discharge, the wires must have quite a big diameter. The diameter is greater for bigger voltages. Corona discharge is used in electrostatic filters, which clean gases of dust and associated contamination. It is also used in diagnostics of structures and helps to detect cracks and splits on the devices. Corona discharge is used in copying machines, that is, xeroxes and laser printers, for charging photosensitive drums, transferring powder from the drum onto paper, and removing electric residue from the drum.